Welcome back. Well, it's a particularly cool and rainy and dreary kind of June Tuesday afternoon. And well, what a better time to sit in my desk here and actually assemble an electronics kit. Now, in a recent video, I discussed RadioShack in town here closing, and I picked up some stuff, including this color organ kit. And I'll put links down in the description to the website. I think you could still find this on there. I got it for a pretty cheap price. Unfortunately, off the top of my head, I don't remember what it is, but I'll put it someplace in the video over here. What this is supposed to do is you input a audio signal into it, and it has different colored LEDs up here, and they're arranged in bass, mid, and treble, and they'll actually blink or flash or whatever depending on the music. And I thought, well, this would be a pretty neat kit. I've seen instructions how to build these before, but you know, when you can get everything in a nice little package like this, of course it's a lot easier. You don't have to do any thinking, you just assemble it. But anyway, yeah, so we're going to put this together today. And I will make note that this is custom manufactured in China for General Wireless Operations Inc., doing business as RadioShack, Fort Worth, Texas. This is one of the kits that they came out with after RadioShack started going bankrupt and some of the assets were switched over to another company. And from what I understand, half the store went to Sprint and the other half the store went to this General Wireless Operations company, and they continue to carry stuff like this. Now, it's unfortunate because this is actually a really nice kit so far. I like the way it's packaged. They had other kits on the shelf. Unfortunately, I never made it back to there, so I couldn't really get anything else. But we will certainly take a look at how this is put together, and I can show you what I mean about how it's nice. First off, they give you a nice set of instructions. We'll take a look at those in a minute. But looking at the actual PCB, it's very nicely manufactured. It has a beautiful solder mask on it. You can barely see any of the traces on there. Now, if you wanted to reverse engineer this, it would make it a little harder. And it is, after all, a two-sided board, so there's plenty of stuff going on here. But it's just nice. All the components are laid out very easily to understand, and it should be pretty easy to put together. Now, I can tell you from looking at this, is a DC jack here. This is your input, and then you have 3 potentiometers over here where you can adjust the signal. These are where your LEDs are going to go. There's obviously resistors for each LED, and you'll have a bank of IC chips. There's also another chip up here. And as we pull these out and look at them, we'll actually show what they do. And the rest of it's all just passive components. There's no links, there's nothing like that. It's all just through-hole mount onto the back side over here. And I think they even give you the little standoff, so let's hope they do. But the rest of the stuff, and this is where it's nice, and I mentioned this before, it's all individually bagged, which is beautiful. This is going to make this kit go together really easy. And you can see, for example, they say U2. This is an LM358P. It's a DIP 8 socket, and it says 1 piece. Well, if you want to solder this in, all you got to do is look for U2, which is right here. So it makes it really easy, and everything here is like that, including the LEDs, everything. So it's really nice. I wish a lot more kits were like this. Of course, I'm used to buying kits on eBay, which you'll be lucky to even have instructions, and everything usually comes in one bag. But I guess those are a little bit more challenging to put together, so depending on your level of fun, they may be more fun, they may be more of a headache. I particularly like stuff like that because I like the challenge. But this is going to be pretty neat to put together. I just want to check one thing though. The DC power jack, it looks like it's a 5.5 by 2.5 millimeter jack here, which I just happen to have on a spool here. Let's see if that fits. It does. So hopefully that will work so we can get power into this thing when it's done. If not, we'll have to fuss with it. So let's take a look at the instructions. Oh yeah, the other nice thing is it comes in both Spanish and English, which is awesome. So we'll take a look obviously at the English ones here. And it's just going to tell you a little bit about this. Required tools, obviously soldering iron, lead-free solder. We're not using lead-free solder, we're using the leaded stuff. I hate lead-free solder. Diagonal cutters, which of course I have. And review the schematics instructions. Attention to detail is critical, and that just goes without saying. And well, if you want to go through all these, I'll show you panel by panel. I suggest pausing if you need to read any of this stuff. I'll try to put a link to instructions down below as well. But there's really not much to it. And they tell you resistors and ceramic capacitors are not polarized, therefore they can't be inserted the wrong way. IC chips definitely have to be put the right way. The aluminum capacitors and LEDs are definitely polarity sensitive, so they have to be put in the right way. And the same thing with the pots and everything else. So pretty simple. I mean, not really much to it. Now there is one thing. If you notice that the instructions show you a cell phone or an audio device with a wire running into the input, but once you plug that in, you're not going to be able to hear this. So you only see it light up. So we might have to use some kind of a splitter or something to actually listen to the music as we monitor it. They do give you a nice diagram here on the back of this. Let's see if I can get that nice and in frame there for you guys. And they point out everything that's here, the resistor values, the capacitor values, where they are all located. And you also get a wonderful schematic. That's just awesome. So if you want to actually reverse engineer this or build one yourself, you certainly can do so by looking at this. It looks like it's just a bunch of op amps pretty much. But I'll definitely try to do some good editing in this video and see if we can actually get the data sheets put up as I pull the IC chips out. And hopefully you can kind of make that out. I mean, I know it's kind of small, but you can definitely follow that along. So we'll put those to the side. I don't really think I'll need to refer to those as I build this. And well, let's get doing this. We're going to start with the lowest components first, which will be, of course, the resistors. And then we'll probably move up to the ceramic capacitors, and then we'll just keep going up from there. I don't intend on doing a lot of commentary as I actually do this particular build, so I'm just going to let the camera roll, and I'll do some kind of editing where we'll actually have this sped through so we can come to the end. And we'll see you guys in just a moment. All right, there's all the resistors in. It wasn't terribly hard. It did get a little hairy where there was a bunch of these together in a row, because I was actually just putting these all in and just folding leads over on the back. So when it came to soldering them in, you had leads going everywhere. So some of them did end up sticking to each other. Not a big deal. So not something I couldn't fix. And I trimmed them all pretty good. You can see they're a nice shape there. I did look through the rest of the pack. There are no standoffs on this, so that's okay. We can certainly get those. So I think the next thing's going to do is actually put in all the ceramic capacitors. So I'll have all these up here and these guys over here. All right, there's all the ceramic caps in, pretty easy. I think I'm going to go over to the electrolytic capacitors now. Now, I mentioned before, those are polarity sensitive, so you do have to be very careful how those get put in. You can see they put a little plus and minus. Now, normally the symbols are a little different because they'll stand tall, but they have these laying down. So we'll have to be cognizant of that. There's not too many here, so that's pretty easy to do. But I'll just show you real quick. I'll take one of these out. This is going to be C4. Actually, it's C4, 12, and 16, but either way. You can see that there's this white stripe on the side over here. The camera will focus in on that. That's the negative side. And you can also tell that because the lead on there is shorter. The positive is the longer one. Now if we go over to C4, which is this one here, we'll put the longer lead in positive and the shorter lead in negative. And to confirm, you can see the stripe faces that negative side. And these are going to go in and just bend just like that. And I'll get the rest of these put in. All right, not too bad with those. Moving on, we could put the LEDs in next. There really isn't any other components to put in other than the actual chips, so we'll get to those in just a moment. And again, LEDs are polarity sensitive, so you can see they have the plus marked out in here. The other side where the negative is, it's actually flat, so if you look at this diagram here, it's flat on this side, round on the other. That's a good indicator. And then the other thing is on the actual LED itself, the positive, just like the electrolytic capacitors, it's just a little bit longer. So we'll go ahead and put those in, keeping in mind the proper colors. Done. Not bad at all. Just gonna have to go ahead and just trim these just a touch more because they're just a little proud of where I want them to be. But other than that, it looks good. So the next thing I think I'm gonna do are the components on this end over here, the potentiometers, the input jack, and the DC jack. All right, there they are. I did have to hold these two in from the back side while I soldered them because there wasn't really any leads, hence why you didn't really see me clip anything afterwards. So that was pretty easy to do. And one thing I didn't mention before, the electrolytic capacitors, I had to actually hold those in from the other side as well just to keep them from flopping around. Okay, now it's time to move on to the ICs, being U2 and 1, 3, 4, and 5 over here. And well, I'm going to put the data sheets up on here, hopefully. First one we have here is an LM358P. And the next one's going to be an LM324N. So yeah, I think I should be able to get the data sheets up on the screen here. So when you put these in, we're going to pay very close attention because these are going to go in a certain way. And if you look at this chip, you can see there's this little tiny dimple on top up here. Hopefully the camera can pick that up. Yeah, it's right there. Now that dimple should point in the same direction as the dimple here does. So this is going to go in this orientation, not upside down like that, but like that. Also, this little foam piece here, this is like an anti-static piece of foam. I'm using an anti-static mat here, and I do have an ESD safe soldering iron over here, so that's one thing to be cognizant of. You don't want to be moving around while you're handling these chips because you could fry them. The rest of the components are kind of inert. They don't really have an issue. And I will notice, I should mention that these are actually all Texas Instrument chips, which are pretty nice. They're not some off-brand chip. So I have to say the components that they use on this are pretty good. Now I don't know about JWCO brand electrolytic capacitors, but everything else seems like it's in good condition. And I will mention, and I forgot to mention this earlier in the video, I don't really necessarily like the way they laid out the component numbers. So maybe if it makes sense in schematic view, but if I look at this, I would have named this like R1, R2, R3, 4, 5, 6, 7, 8. You know, I would have put all the like numbers. If you notice, R1's over here and then R2 is nowhere near it. It's a completely different spot. So when I was looking for stuff like that, it was a little bit more fiddly, as I'll say, to try to actually locate everything. But certain things like VR1, VR2, VR3, that was pretty simple and easy. It's right there in a row anyway. But yeah, that was one little thing that made it a little difficult. But other than that, not too bad. So yeah, let's get these IC chips in and call this project done. And that's it. That's everything put in. I have to say that was a really, really easy kit to put together. And if it looks like I kind of flew through it, I kind of just really flew through it. This was all done in just one sitting. Now, the one thing I do have to say I did do on these IC chips, you may have noticed, I actually just tacked in 2 corners of each, so the top right and the bottom left of each one, just to hold it in place. I could flip this over. And then what I did was, as I was over here, I wanted to spread the heat out. So I went one pad up here, then another one here, and I just kept like randomly going around, so that way I'm not spending too much time on one chip, because they can get quite hot and heat could actually affect these things. They are very sensitive. Once you get them put into a board like this, they become less sensitive because they have, you know, everything else here to kind of help dissipate ESD and stuff like that. Not that you can't still fry the thing, but you have less of a chance, I'd say. But yeah, so now we're going to go ahead and get this thing powered up. Now, I believe it does run on 12 volt. I'll have to check that. And if we look at the back over here, it does have a little diagram indicating that the center pin of this is actually going to be positive and the outer ring is going to be negative. So we do have to make sure we set that up the right way. And eventually I'm going to actually go ahead and clean all the flux off of this, because it's kind of ugly, but yeah, we'll get that cleaned up too. And I thought about it, and I think I have a headphone adapter where you normally can split the output of something into 2 different ways. Now we can try that and see if we can get this thing to either split from here or whatnot. Okay, well, I got my power supply hooked up over here. As mentioned, tip is positive. And let's see what happens when we plug this thing in. Hopefully it doesn't blow up. Oh, cool. So now if you notice, the indicators here went up and down. I'll go ahead and show you that again. All right, so we know the thing kind of works so far. So what am I going to use for an audio source? Well, YouTube is a fickle thing when it comes to copyright. And I could use something that I wrote myself, and I have featured some of my music on this channel here, but I'm going to go do something a little different. I have something called the Pocket Operator Arcade, and that's this guy over here. I don't intend on doing a video on this because, frankly, there are plenty of videos on this thing and a ton of people out there that operate this thing way better than I can. But what this essentially is, it's a little miniature synthesizer kind of thing. And I'm sure you can hear it. It has a little built-in speaker. And, well, it has an audio output as well. So what I'm going to do is just take the audio out of this, and using a splitter like this guy here, I'm going to plug that in, and then we should be able to split this off to my little Boom P3. What I'm going to do is take the audio out portion of this, which just loops up and comes around and goes back in again to this volume knob. And I'm actually going to take that out, and I'm going to hook this into the output of this device. And I have another cable up here. We're going to take that and plug that directly into our little box over here, and plug this back in and turn this guy on, and we should see these little LEDs dance, hopefully. I might have to turn the volume up on this thing, which, if I remember correctly, is this button. So okay, it does seem like it's working. I'm just going to lower the volume down on this guy here. Well, so low you can't hear it, excuse me. And let me just kill some lights here to make this a little easier to see. We'll go with one of the factory presets on this thing. So yeah, it does seem like it's working pretty cool. There is some adjustments here, so let's see if we fiddle with any of these, what they actually do. So if we want to fine tune, let's say the bottom one's for bass over here. Yeah, we can get that just where we want. I had them all set right about the midpoint originally, which is where it is there. So that's not too bad. Now there is a good amount of volume going into this thing, so perhaps if I want I can lower it down a little bit. I know this isn't the best kind of test, I guess you could say, but it's going to give the kind of feedback I want, at least right now. Yeah, so yeah, it definitely seems like it's working pretty good. I mean, I could always go on to the YouTube music library and download one of their rights-free songs, I guess you could say. But yeah, that's pretty cool. Seems like it's working. If If you want more information about the pocket operator, I'll try to put a link in the description below to another video where it features what this thing actually does. But it's basically a little chip tune generator. My favorite sound on this thing is the Mario, I call it the Mario Fireball kind of effect. And using the knobs, you can actually change the pitch of it. Yeah, it's just a cool little device to play around with. But yeah, so far that's a really cool little thing. I like that. You know, it's a nice kit to put together. Did I learn anything from it? No. You have to design these kind of things if you really want to learn how they operate, you know, or go through the schematic or stuff like that. Perhaps in another video, if you guys are interested in it, we can kind of do a little bit of reverse engineering, look at the schematic and everything, and explain how this really works. I don't think it's really too complicated. If you look, you know, all these components are kind of the same here. The way everything works here, it's pretty simple. I mean, you have, well, there's more op amps here than there actually is lights, it looks like. So I do have to figure out how this is actually working. You figured it'd only be 3 of them and not 4, but it must be just the amount of outputs this thing actually has on it. But yeah, fun little kit to build. If you're looking for something to just nip together in a couple hours, this would definitely be it. Well, with that, guys, I want to thank you for watching. I don't really have much more to add to this particular video at this time. If you are new to this channel, if you just happen to come across me, well, welcome. And thanks for sticking along to watch the whole video. If you want to subscribe, I'll put a link right here to subscribe. I do have another channel, PTS Extras. I'll put a link over here, and that has extra stuff on there that you might find interesting. And I'll also put some extra videos on the side over here I wouldn't mind you guys checking out. Well, thank you for watching, and we'll see you guys next video.